I don't know if I did say, I'm from the Notts and Derby section. Did I say that? I come from Nottingham. I'm in the Notts and Derby section, but I've never worked there. I joined the railways in Manchester in 1978. Right, I put this up as food for thought, because when I looked at the presentations, I thought there's lots of good stuff about what we're doing, and there's other things we're doing that aren't in there. When I travel around and I see what's happening at Reading or Thameslink or Crossrail, or we even had didn't we have Phil, is it Holborn here one year talking about Acton Dive Under and all these things to increase capacity and remove bottlenecks on the network, and things that I wouldn't have thought we'd ever get round to doing when I was in my 20s and 30s. So there's a lot going on. I put this up there and you probably think he's mad. Why is he putting up things up there with 2065? Is that a typo? Well, it isn't. And I did it for a reason, because I talked to a lot of young people about being a railway engineer, people who've just joined the industry, some graduates and some other people. And I'm trying to think, what will the world be like for them when they look back after their career? And I'm assuming that all you young people in the room will work for 50 years. Is that a bit scary? It scares me, and then I think, well, I've done nearly 40 and I've never been scared during that time, so maybe it just goes by, I don't know. But people joining today, my children who are just leaving university now, will actually go and work till 2065. And so I thought, well, 40 years ago when I started, if I'd have had to guess what the railway would look like today, what would I have been anywhere near? And would I have had an understanding about what was going to happen? Bearing in mind there wasn't computers were very rare then. They were held in one at Manchester University where I was studying, but it was nothing like the world we know today, nothing like it. So I just put some crazy stuff up, and I haven't made it all up. And I know it's a bit wishy-washy, isn't it? But I haven't made it up. I've talked to people, and so genetic engineering, what society will be doing in 2065, I haven't invented that. I used to talk to university students a lot and used to ask them what did they think would be the big invention in their life, or the big development, and I always thought it was computing. That's what I used to say. But actually it's not that now. It's about the internet, isn't it, and the cloud, and how you move data around in the world, So that's gone past computing, really. And it's amazing how they nearly always come up with something to do with genetic engineering and what we're going to do with people and bodies, and how we're going to fuse in prosthetic limbs into the actual body and how we'll control them and that sort of thing there. So you think, that's going to be interesting, isn't it? I know it's not track engineering, but so. And when oil goes, increasingly people are saying we will make fusion energy work. It scares me a bit. It's the power of the sun. But if we get there, it's going to be a whole different world, isn't it, from where we are today? And I'm talking about in 50 years' time. So, and I thought that today the presentations we've got aren't really scanning that far forward. But because of the group you are, I'm hoping you might have a few comments to make about it during the questions and things, and see how you can take what we're doing today into what will happen in 10, 20, 30, 40 years' time. So, the big changes that I see in track, and I see this happening now, and I have done for some time, that when I say more complexity, I think it's more difficult to be a track engineer now than it ever was, because you get swamped with data, and it's hardly started yet. So, and data is really useful, of course. Well, it is if you turn it into the right sort of information that you can use. And at the moment, I give us a score of about 6 out of 10. There's a lot to go. So, and I'm thinking at the moment, when we get data, drink of water, can't talk. I've got a bit of a cold. So. When we get data, we take a data cut, we post-process it, we measure it at different intervals, and then we turn it into information. And it all seems a bit long-winded to me, even now. And the amount of data we can process now is light years ahead of where it was 10 years ago when I first started thinking about it. But we're not good. We measure data, so for track, we measure a lot of track quality data. We measure it, we take a cut of it, we post-process it, and it's complex, isn't it? Because those of you track engineers, you'll understand that if you decide to cut the data today, and you're taking the latest run on every line across the country, if you don't take the data today and then somebody else takes it tomorrow, you'll have done another 10 runs or something, and the world will be different. So, and at the moment, whenever we change data and we process it, it introduces errors, or not necessarily errors, but interpretation issues. And we generate things, we find suspects, and then we go out and verify them with people. So I don't see that world carrying on for very long. We'll find defects, and we won't find a suspect, we'll find a defect, and it'll be a defect, and we'll send something out to mend it. So robotics, people think, robotics, come on, how's that going to be used in track? And then I went to my first presentation a few weeks ago, and somebody was talking about a machine that will put on the track, a robot. It'll go down the track, find the defect, a railhead defect, repair it, and come back. Not with people, not one you drive, a robot you send. And I was a bit scared reading in the Times the other week. They're talking about the use of robots in the military environment, and they're saying from very low-level robots that just do things like sweep the barrack room floor to high-level robots that make a combat decision without reference back to a human being. Wow, that's Arnold Schwarzenegger stuff, isn't it? Terminator stuff. And you think, how's that going to apply? But I'm absolutely sure we will have far more robotics in our world than there are at the moment. So, there's a subtle change here. You know, for a while we've had a predict and prevent strategy in how we measure track and how we respond to track geometry faults. And we're moving away from predict and prevent to measure, monitor and prevent. That's about finding a defect early using risk-based maintenance and understanding the P to F curves. Hopefully some of you know what that is, you know, from the point at which you can first detect it to the point that it fails. So it's about finding that, and then depending on where it is, we will decide when to intervene. Because we'll need to intervene when there's a suitable access arrangement. And the time at which you need to intervene is very different if you're in the throat at Waterloo from if you're somewhere on the far north lines in Scotland, because the traffic levels are different, the speed's different, the track construction's different. So in the future, engineers will have a lot more power to decide when they intervene, because we'll monitor a fault from finding it very early on. And we have, in Network Rail, we have actually monitored, we have actually written down the types of failure for every fault you get in plain line, every fault you get in S&C, and we've drawn the P to F curves, and we've got a view about how they are affected by in different locations across the country. It's part of the devolved railway. It's giving the routes the power to decide when I find a defect on my route, I can respond differently from how you'd respond on another route. I come in the middle because I set the critical limits and say there are things in track. When you find that fault, you mend it. You put a speed restriction on, you shut it. That's where I come in. So, I guess, you know, we should never isolate ourselves from what's happening in signalling. Somebody tell me the time. Can't break my rule here. Oh, we've got a minute to go. That's good. So, moving block signalling. Mark Carr's just issued a statement on ECTS. It is in ETCS, European Train Control System. I get, you know, they change the name of it every so often, don't they? But I have no doubt, because I was the managing director of Docklands Light Railway for 2.5 years, and I've seen what a railway is like when you run it with no drivers, with no signals, just being controlled by an onboard system, and it's a better railway. But doing it on the DLR is nothing compared to trying to do it on the main line. But we will get there, and it will affect us in track, because it would be different if there were no signals. It would be very different. So, just a couple of things at the end there. The biggest thing that I see, the biggest opportunity I see for us in track at the moment is plain line pattern recognition. It's been around for 20 years. I was saying to Dave, I remember going to the first presentation I ever saw on it was by Paul Leach. So Paul Leach, who's unfortunately not here anymore, but he gave a presentation. At that time, all the issues were to do with we couldn't get the data, we couldn't handle the volumes of data we'd collect. And there was an issue about cameras and lasers and things like that. But what we do now, we've solved the technological problems associated with it. It's good enough. You know, if you were Apple, you'd be issuing it and selling 20 million and then start working on the next one. In 2 years' time, you'd sell 20 million more when that first one broke. And so it's good enough. I'm sure it'll get better. But I find it quite mind-boggling that it takes a high-quality digital image every 0.8 of a millimetre. I think the old system I learned when I was a young engineer was that we were taking readings every 8 inches, 200 mil, wasn't it? Every 0.8 of a millimetre, and it's chucking all that data into a system, and then we're post-processing it and giving information to the routes. And that's just, you look at that, you think, what on earth is that? Well, you know, it's two rails, and you're looking down the track there, and that just shows you the sort of the level of coverage you get. It's fantastic. Fantastic. But I do appreciate it's not a human being. It won't stand up and look around. It won't see a broken boundary fence down there. It won't see a blocked drain down there. It'll only see what you pointed at. So it's a change. It's a big change for us. And we're only just starting the journey, I think. So, okay. I don't know if that's a keynote address, but it's my thoughts. And I hope that I've provoked some thought that you might want to comment on in a bit.